All right. Well, hello, everyone, and welcome to the August 2021 edition of the Houston Java User Group meeting. Welcome. This meeting is being sponsored by Improving, my employer, full disclosure. They're a great company to work for. We're currently hiring Spring Boot developers. If you are familiar with Spring Boot, please feel free to reach out to me over LinkedIn, and I'd be happy to pass along your resume. Or if you have any questions about improving or working at Improving, let me know. It's consistently been voted the best place to work by its employees here in Houston, and I just love it. And tonight we have Marcus Kett and Florian Haberman from Microstream here to tell us all about Microstream, their in-memory database that has recently been open sourced. Marcus, Florian, take it away. Thank you.
Thank you, Jim. Thank you for introducing us. Yeah, it's absolute fantastic to be selected and to be here at Java User Group Houston. Unfortunately, not on site. Hopefully next time. Yeah, this talk is all about build ultra fast Java in-memory database apps and microservices with Java. And let's have a look first on the agenda. First of all, I'd like to talk a little bit about the challenges of database programming in Java of today. And then I like to introduce you to the new concept of pure Java in-memory data processing. And then I'd like to talk a little bit about our open source project, Microstream. We have prepared a live demo. We talk about this live demo, and then I jump into the working principle, and Florian will show some code, and then we have enough time, I think, for a Q&A. So yeah, if you have any questions, yeah, please feel free to interrupt me and ask your questions, so we can make this talk interactive. So I prefer that. So my name is Marcus Kett, and I'm a CEO and co-founder of Microstream. And I'm also very active in the Java community. I'm editor-in-chief of this beautiful Java magazine, and it's the very first free printed Java magazine. It's unfortunately it's in German language, but we have plans to run it as an English edition as well. The Java Pro also is organizer of the Java conference JCon, and it's the second edition of a virtual conference, and it's free for all Java User Group members. Florian is our CTO, and we are working together since almost 20 years and working on Java developer tools. So Florian is really he's a geek, and he has developed 2 complete Java development environments. The first we wrote it in based on Java Swing, and then we migrated the entire stuff to Eclipse. So this is almost 8 years ago or so, and our goal was always to create a visual Java development environment. So yeah, kind of like Visual Basic for Java. This was actually our goal, and it always was pretty easy to build this really comfortable GUI builders, and so everything worked fine. But as soon as we wanted to have access to databases, then the horror begins. And so this was the reason why we spent lots of time with improving the JBoss Hibernate tools, and to make it easier and to accelerate the Hibernate and EH cache through the runtime. This is our background, and almost 10 years ago, we started with Microstream with a completely different approach. Yeah, here you can see Microstream at work. So mostly it's fun and conferences. We love coding conferences, talking about our stuff, of course. And here again, you can enroll for a JCon conference. It's a 4 days conference, and also the workshops are free for Java user groups. So check it out, enroll for free. And we have another gift, and it's this is supported by Fastland. It's an education company, and here we have about 1,000 tickets for free. So you can check out an online course about a microservice framework, just like Quarkus, Open Liberty, Payara Micro, Spring Boot. You can book it for free. Wow. And you only have to use this booking code, use this URL, and use this booking code, and then you can choose any course and book it for free.
Wow, that's amazing.
Fantastic. Yeah, cool.
Thank you.
But back to our main topic today. And so why is performance really necessary and so important? So many people ask me, so why is performance so important for you developers? And I think it's the modern software applications, they produce tons of data and must consume tons of data, and so we have to analyze data in real time. And the faster the systems are, the more powerful the systems are. It's all about AI, machine learning, virtual reality, and so it depends on how fast are we able to analyze, to query, to analyze our data in real time, in the future. And many people, they ask me, hey, why are our database applications are so slow, and why is database programming in Java so complicated? It's so time consuming, and we spend lots of hours, most of our time with performance issues. And in all conferences we have these performance talks, Hibernate performance tuning, and so and then when we see when we have a look on cloud computing, then more and more companies, they use cloud computing, but they're the costs are increasing more and more. The costs, the infrastructure costs explode. Why? It's, I think, because our systems are so inefficient, and this is the reason why we are working on this issue since many years, and our goal was to improve that. And we believe that Java actually is super fast technology. So our investors, even our investors, they ask me, hey, is Java really fast enough? Is this a dinosaur technology? Should we really use the Java technology? I think, hey, people, are you crazy, guys? Of course, hey, Java is a super fast technology. We have this JIT compiler, and JIT compiler makes your application super fast. It's almost as fast as a C program. So where is the problem? And we strongly believe that Java is already the perfect technology. We should use it. So we should use the power of the JVM. And I think today the power of the JVM is not really used for data processing. We also have the perfect data structure, right? It's Java object graphs. So the database vendors, they invent more and more data structures, and so these data structures are incompatible to our object graphs. And this is the reason why we have to map our object model to these database specific data models. And mostly then we are in trouble. But with the object graph, we already have a multi-model data structure. So the databases, the database vendors, they mostly provide one data structure they believe in, and they think this is the best data structure for our users. And then they see even in this microservice field, we have to use very different data structure. And now the database vendors, they are working on a multi-model concept. And but in Java, we have this already from beginning. And you can use you can build it freely. You can design your object graph freely. You can use all Java types. You can, if you want to build a simple index, use a list. Or you also can use very complex data structure. So everything is possible here. And additionally, we have the perfect query language. So the database vendors, they are forced to invent their own query language. And these query languages mostly don't work with Java. So this is the reason why we have to build a Java API on top of that. And so we have to wrap the databases actually. And with Java, we have the perfect query language. We have the Streams API. And with Streams API, we can query object graphs in microseconds. So have you ever measured how fast it is when you have, for instance, a terabyte data in memory, and you have a complex object graph, and now you have to query your object graph. It really takes only microseconds, mostly. And this is much faster than any in-memory database can be. So this is my opinion. So if you have a different opinion, so please interrupt me and let's talk about that. So this is very interesting and helpful for us to hear what you are thinking about this topic. So what's the problem? Why don't we use that? It's persistence. We are used to use external database systems to store our data. Actually, it's strange. I think so. We have Java. It's the most powerful programming language. We can do everything with Java, AI, machine learning. But as soon as we want to store data, this is not possible. You have to use an alien system that works totally different, only for storing data. And I think this is the core problem. In Java, we love object-oriented programming, right? So type safety, this is very, very important for us. Standards are very important, and POJOs. So avoid dependencies, and we love to build elegant object models, clean code. This is very important for us. But as soon as we store data, we leave that way, and then we use systems. They are not object oriented, right? They are. We have query languages. We have to include query code into our Java code. This is not type safe, right? And we have heavyweight dependencies. So I think a database system is really a heavyweight dependency. And sometimes using SQL native code in your Java code, this is not really good testable and not really elegant, and and this is the reason why we thought about, can we make things different? And let's have a look on the core problem. And here we can see the architecture of a traditional Java persistence. And here we can see we have these object graphs in Java, and when we want to store data in the relational database, this is not possible. We use tables, and it's not possible to store complex object graph in tables. So we have many impedance mismatches here. And what's about NoSQL? I mentioned it already. They use a different data structure. But all of these data structures are also incompatible to Java object graphs. So for instance, they use JSON or XML or key value. A graph, even a graph database is not, this model is not compatible to the Java object graph model. So it's they use their own graph models, and it's the same with these object-oriented databases. So many people, they ask us, is Microstream a kind of like object-oriented database? It's not, because the object-oriented databases, they use their own object model, their database-specific models, and this is the same with all databases. They use their database-specific data structure. Microstream does not force a developer to use any database-specific data structure. This is the big difference. And to solve this problem, we have this object-oriented, object relational mapping frameworks. And of course, Hibernate is the de facto standard. And with my team, I have working on improving the JBoss Hibernate tools and working on object relational mapping frameworks for 10 years or even longer. We have also measured the time. How long does it take to generate these objects? So the database vendors, they measure the time. How long does it take to execute the query, the SQL? But nobody measures the time. How long does it take to generate the objects behind the scenes? And even when we have access directly to a cache to accelerate our system by using local caches or distributed caches, then it's very interesting to see that the access time is not as fast as we would expect, because I have learned if you have access directly to memory, then it should take only nanoseconds, or okay, assembler is executed in nanoseconds. But if you have access to cache, it should take microseconds, right? But when we have measured how long does it take to read only to read data from a local hot cache, it mostly takes milliseconds. And hey, what's the problem here? And yeah, the problem is that we have this object relational mapping even when we have access directly to local cache. And this is the reason why, this is my opinion, this is the reason why our database systems or our database applications using Hibernate, EHCache, why these systems are that slow, and why we have to spend so many times with performance issues. It's because of the system is, we have incompatible systems, and the system is inefficient. And yeah, in Wikipedia we have a really nice article about the topic. And as soon as the problem exists, I mean the problem of incompatible systems, we will have the problem that our systems are getting more and more complex, or the performance goes down. So you cannot avoid that. And for developers, we have the problem that, or the challenge that we have to implement actually our data model twice. So we have to write the Java classes, and then we have to implement the data model on the database side as well. So,
and that's if you're only dealing with the database. If you're having to deal with other systems as well, you may have more than just this. It gets kind of headache. It can become a very big headache very quickly.
One more interesting thing is that with Java, actually we ignore, I would say, half of all functions a database provides. So the database vendors, they tell us, hey, use store procedures and put your business logic directly into the database. So because it's executed super fast, And I'm convinced you guys, you love it. So you love stored procedures, right? So no, mostly we do not use stored procedures. So we have competing concepts, and the Java standard ignores half of the, I would say, half of the feature of a database, and it's because we want to do it in a Java way. So actually, we want to abstract the database. The idea is to store objects, and this is why we call it, we store objects by using Hibernate. We store our objects into a database. From a technical perspective, this is not true, but this is the basic idea behind the concept. So not getting in contact with the database. Yeah, and so okay, these are this is the standard. So we can use relational database with JPA. We can use NoSQL database systems. Now we have stream processing. We can use distributed caches, and all systems have the same challenges. Incompatible data structure, and so we have to map our objects to the database data model. So can we make it different? So this was the main question for us to simplify the entire database programming model. And yes, we can do that. We can do that different, but then we have to think different. And as I mentioned already, with Java, we have everything we need. So it's core Java. Everything is here. We have a perfect data structure. We have a perfect query language. And an old Java developer's dream is now we need persistence. So let's persist our objects by using Java serialization. Simply, we have a simple object model, only Java classes, nothing else, and serialize the object graph. That's it. Super fast, super simple architecture, perfect. And many developers, when we talk to the developers at the conferences, many people they tell us, "Hey, I had this idea already 10 years ago. That's really great, but it doesn't work in practice, unfortunately." And then we found even a pattern for that. It's I don't know if you anybody of you know system prevalence pattern. And in Wikipedia we can find an article about system prevalence, and yeah, it describes a system that is a pure Java system, and keeps the system state in memory, and it uses snapshots to persist the objects and to restore the objects in a memory again. Yeah, and it looks quite simple. It is really simple in comparison to all other persistence approaches. And Martin Fowler also have written a blog post about a system that works as a prevalent system. And yeah, he was very excited about the performance of that system. And it was in 2011. But what's the problem here? So why is it not that popular? So there are many challenges with system prevalence. So it's about the snapshot size. So snapshots are mostly too big. So it does not feel really elegant to use snapshots to store your data, right? And between the snapshots, so you can lose data between the snapshots, and every snapshot is a kind of like latency, and yeah, you have to keep the system state in memory, which means you must load all your data. You enter the database into in a memory, and so this is a problem mostly because of the memory size. So if you don't have enough memories then it's a problem. And if you have enough memory, then yeah, perhaps you run in garbage collector issues. Then you have the problem. What's if the class changes and the storage size grows more and more? And then we have the serialization issues as well. So Java serialization, we know is not super fast. It's not secure. So actually, Java serialization is one of the biggest security issues in Java ever. So there are many challenges, and I think personally, this is the reason why system prevalence is not really popular and not used in practice, and it doesn't work in practice. So with Microstream, we eliminated all these issues completely. And this is a game changer. And this actually is Microstream. And so this is a kind of like system prevalence 2.0, I would say. And let's have a look on the history of Microstream. We started the project in 2013, and yeah, as a hobby project. And but some years later, so we have experimented with our Java development environment, wanted to improve data storage, so we worked on Microstream. And 2 years later, we used Microstream for the first time in a very important project, and we were able to solve a huge issue, and we saw how fast it is. And yeah, first I thought it's the performance is Microstream, or it comes from Microstream, but this was not true. It's actually the performance of the JVM. So when I saw the speed demo and the data, then I thought it must be a mistake. So it can't be that fast. But it was true. It's the performance of the JVM. Then we founded a company some years later in 2019 and launched Microstream as a final release, as a freeware. It was still closed source, but freeware. And it's because we're located here in Germany, and we have German investors, and they don't feel comfortable with open source. So it's sometimes difficult. So all investors here in Germany, they want to protect your invention. So how can we keep this a closed source and not to open source it? So, but we were able to convince the investors, and now it's open source. And so we also use open source for 10 years, and we love open source. Everybody, all developers love open source, and now we are really proud and to be part of an open source community and run our open source project on GitHub, of course. And yeah, currently we work on an integration with project Helidon. Here we work really close together with the Helidon team located in Prague, and it's almost finished. So I expect that the next Helidon version will be with Microstream, and it should come in I expect in September or so. So in some weeks we will have the first Helidon version with Microstream, and
yeah,
we also
maybe about 2 weeks from now.
Oh, okay, cool. And we also still working on an integration with Open Liberty, and working close together with the Open Liberty team. And now we're working together with the Payara micro team. And we are also working on an extension for Quarkus and Micronaut and Spring Boot also. Yeah, here is our GitHub site, so you can check it out and join our community and yeah, use it. And of course, please star us on GitHub. So this is very important for us. Yeah, I mentioned already, we're working together with the microservice framework vendors. And now let's have a look on Microstream. How does it work? So what actually is Microstream? Microstream is, or the core of Microstream is a serialization. It's not Java serialization. We have written our own serialization from scratch, so it's fundamentally different and it really works fundamentally different to the Java serialization. And this is the reason why it is much more secure and it's much faster. It's almost 25 times faster than Java serialization in our performance tests. So it depends on the use case, of course, but check it out. So it is really much faster and it's much more secure because it works totally different. It's not possible to inject malicious code through runtime through deserialization. So this is the reason why you can use Microstream serialization also for not only persisting your objects, also for transferring objects and synchronize your object graphs between two JVM states.
So could you use this library as a standalone library outside of the context of Microstream?
Yeah, sure.
Really? Great. Wow, that's really impressive. That's fantastic.
Yes, and on top of that serialization library, we have a communication layer, so you can use it for synchronizing your object graphs between two JVMs. And this is very interesting if you work on a IoT project, for instance, where we have a server-side Java application and where you have access with mobile clients written in Android, and you want to synchronize your object graph easily, then you can use Microstream for that. So we have implementation for the JVM and also an implementation for Android. And on top of that, we have a function that we call it legacy type mapping. And because one of our biggest problems was, what if our classes change? So we have different versions of our objects in the storage, and then we are in trouble. So with this legacy type mapping, we have solved that problem. So this is solved by the engine through the runtime. So you can choose your classes anytime. So this is won't be a problem. Then we have a file system abstraction, and we also have a kind of like garbage collector for the file storage, because we store the object appended to the file storage. And as I mentioned, if your classes change, you have different versions of your objects, and you get legacy objects in the storage. And with this garbage collector, the legacy objects are removed from the storage. Then I mentioned already, it's a file system abstraction, so you can store your objects in plain files on a local file system. You also can run Microstream in a container and store it in a different file location. And you can also use database systems to store your objects. So we provide database connectors to all major database systems. Then on top of that, we provide a REST API, a REST API and REST interface to access the storage data, and on top of that REST interface, we provide a user interface you can use to browse through your storage data. And then we have native backup functions. So you can use these native backup functions, or you can use a database system and can use the backup functions of this database system. So it depends on you. It's your choice.
Basically, you can say every system which takes a binary data you can write into. So in an AWS S3 different blob storage systems, into Kafka if you like, or blob stores in databases and so on. Basically everything which takes binary data.
Yeah. The first implementation was, of course, plain file storage, and we thought we never have or want to store the data in a database. It makes no sense because we do not use their database data structure. So why using a database system? But then we saw that in real world projects, sometimes you have to use a specific database system because yeah, it's the policy of your company. Then because you have already bought Oracle licenses and you have to use it, and the Oracle guys, they do not care for how you store your data. So you can use their graph layer on top of the Oracle database, or you can use Microstream on top of that, and yeah, use the database. So then they are fine. And you can use AWS S3, for instance, to store your data. Then it's you don't have to care for backups and for high availability. So this is all is done by the service, and so it really makes sense. It can make sense to use a database system or a cloud blob storage service. Here is the architecture of a Microstream application, and this looks pretty simple, and it is really simple because we only have the application or the microservice, the business logic written in Java, and then we have our object graph and in the memory, and nothing else. And you only have to include Microstream. You can download Microstream via Maven. It's a tiny Java library, and it runs within your application JVM process, and that's it. You don't have to add a caching framework, so it's not needed at all. You only have to use core Java functions to write your application code, and yeah, that's it. And we can use a relational database system, NoSQL database systems, and even distributed caches or Kafka. So here we have the supported storages, and Microstream runs wherever Java runs, where we have a Java virtual machine, and it even works with GraalVM native images. So it's still challenging to use Java serialization with GraalVM native images, but you can use Microstream serialization with GraalVM native images, and this works really fine. And the only requirement is Java 8, so that's it. Of course, you can use other JVM languages. Our tests based on Kotlin and Scala as well. And also we have tests based on Android. And now we should have a look on a performance demo. I think it's time for a demo. On our website, you can see a performance demo, and here we have two apps running behind the scenes, and the yellow bars, it's a standard Java application. It uses Hibernate, with EH cache as a local cache. And here we have a hot cache. Of course, this app is running already, and we have a hot cache, and then we have Oracle database. And the other application is running with Microstream, and we also use an Oracle database. And you can see the query code, and the object model looks different. So Florian will show you some code after the introduction, and then we can jump a little bit into the object model. It's different because now with Microstream you don't have to adapt our object model to the relational model. So this is the reason why we can now design our object model freely. It looks a little bit different and more elegant, but the performance is incredible because now with Microstream we use an object graph, we query the object graph, and it's really much faster than JPA queries. Here we can see all queries are executed sometimes 10 times faster, sometimes or 2,000 times faster than the JPA query. And this is really really huge and really incredible. And this works with all of your use cases. So check it out and play around and build great applications. So what are the benefits? So really our investors, they have asked us, so what can we do with performance? Looks great, but is performance that important for you developers? Yeah, hopefully. I would say yes. So we can, with performance, we can build applications that were science fiction some years ago. So when we think about the smartphone, this was not possible 20 years ago. So everything depends on performance. The faster our systems are, the more powerful the systems will be. And so you can increase your performance if you increase your hardware power. But this is expensive, and Microstream is an approach to improve your the efficiency of your software. And if you run your application in the cloud, then CPU power is expensive, and instead of copying machines instead of copying machines,
having to scale out, basically.
Yeah. So you can run the same application on only one single node, and this is not only some data on a slide. This is a real world project we have with this insurance company Allianz in Munich, Germany. This was we were really happy when they wanted to use Microstream, because yes, we started as a startup company, so you need a project, so you need revenue, and we were really excited about this project. And then we saw this application runs on only one single machine with 4 cores, and we didn't earn a lot of money with that project. So we saw how fast Java is, and this application is used in 22 different countries by about 1,000 concurrent users, and it runs on only one single machine. This is not true, because we have a second machine as a failover concept, so it runs on 2 machines actually, but we save them almost up to 90% cost of infrastructure. And this is also huge benefit for companies who run their applications in cloud and have to save cloud costs. Everybody wants to save cloud costs, right? And for developers, it's really simple architecture. It accelerates your entire development process, and it's fun for Java developers. Mostly, it's not suited for database freaks. So if you're a database programmer or a database specialist, then perhaps it's not the perfect approach for you. But for Java developers, I think you will love it. And now let's see how it works. I've never seen a database where you have so less to write so less code. So it's really simple. This is a simple class, and this is how your classes look like. So there are no annotations, right? You don't have to use any super classes or interfaces. Really, you can use pure pochos without any dependencies, and this is really plain Java code. And this is also different to the object-oriented or graph databases who don't have to use super classes or implement specific interfaces. Beautiful code, and if you want to store data, you only have to call one store method to store your object or your subgraph. And it's an atomic operation. So every store is we serialize the object or the subgraph only, and only the delta is stored appended to your storage. So all stores are single blobs where we write appended to the storage. And if you call the store method 100 times, then you will have 100 more objects in your storage. And this is the reason why we need a garbage collector that removes the legacy, the types from your storage to avoid that your storage grows more and more. So it's transaction safe, and you can accelerate the entire I/O process by using channels. And this means this is multi-threaded. So the more cores your hardware supports, the faster I/O operations will be. It's a really fast initialization. So it's almost as fast as your SSD disk will be. So it's almost the same speed. Yeah, here we can see we add the blobs to the storage. And here is a slide where we can see how the channel works. So the more cores you have, the more channels you can use. And
for example, you can write to 4 different S3 buckets in parallel and speed up your I/O with 4 different connections, for example. Yeah. That's basically what a channel is. On a JVM side, it's a thread which operates on an object graph, and on the storage side, it's basically an I/O layer or connection to your storage.
Yeah, you also can configure how Microstream organizes your files on disk. So this is not only one file where you have all the data in one file. So this we use numbers of files, and you can configure it in detail. So how to load data into the memory. This is very interesting. because with Microstream now we support lazy loading, so you do not have to load all your data into the memory. You can do that if you have enough memory. Yeah, it's recommended to do that. Then your system will be super fast, no latency. And but if not, then you can use lazy loading, and then the principle is a little bit similar to Hibernate. So then you can decide which object references you want to load eager or lazy. So it depends on do you need the data or don't you, or do you want to load the data on demand when it's needed? So it's your decision, and it's very simple. So to use lazy loading, and when you start the application, then the entire object graph is actually created in memory, but only the object IDs will be loaded into the memory. And when you access to your object, then the data will load it by the engine automatically behind the scenes, and then your loaded objects or subgraphs are merged directly into your object graph. So you don't have to deal with object copies. This is very convenient. You only have to call your get methods, and everything else is done by the engine behind the scenes. So there are no more classic selects we use in classic database systems. And again, we can load the entire database into the memory, but with Microstream this is not mandatory. So if you have a terabyte of data in your storage, then and only have 32 GB of RAM, then it's not a problem with Microstream. Load the data you need with lazy loading, and then you also can load only the object IDs without any data. For instance, if you run a microservice that stores data, then you have then it's very important that your microservice starts quickly without latency. Then don't load data initially in the memory. Use lazy loading. Then you're fine. And queries, yeah, I mentioned already, you can use Streams API. You also can use GraphQL, for instance, to allow yeah, third-party applications access to your application by REST or GraphQL. And with Streams API, it will be super fast. So query object graph, it will take only microseconds. Memory management, you don't have to care for memory management. Everything is managed by the JVM. So, but you have control about what's going on in the memory. So you can load your object references lazy into the memory, and then you can also you can clear your lazy references to save memory. So you have fully control on your lazy references, but everything else is managed by the by the JVM. And if you have concerns about big memory sizes because of garbage collector pauses, then yeah, try Azul JVM. We're working close together with Azul, and they told us they are able to manage 20 terabyte of memory size without garbage collector issues. Wow, this is really great. And with this performance, you can build really incredible fast systems. Too much slides. Let's jump into code. I guess you guys want to see a little bit how Microstream works.
Yeah, actually, so before we do that, it might be a good time. Jared had asked, he said, this is super cool. How does it compare with DBMSs in terms of data integrity?
So do you mean transaction safety? Basically, Microstream is ACID. transaction safe has a journaling system in the background, which ensures your integrity of the data. So you can shut down the JVM, and if the journal isn't updated, the partially written stuff will be discarded later on. And so you can ensure the data integrity, of course. Yeah.
Okay, great, thank you.
All right. So yeah, if you have further questions, just jump in, and I will show a little code we have online on GitHub. So a good starting point is always, of course, the reference manual. Like Marco said, just use Maven or your favorite building tool and add Microstream as a dependency, and you're good to go. And there are two types of learners. So you have the manual readers. Go ahead and browse through the chapters, or you're a code reading guy. And there are two starting points which I can show you. In our main repository in Microstream, we have included our examples. And there you have the most common use cases: simple hello world, how you can access different file system, how you use legacy type mapping if your classes change, lazy loading, and so on, bit by bit. And these examples are linked in the reference manual as well in the different topics. But if you want to see how you can design an application from scratch, we have a bookstore demo. There are some technologies combined, working with Microstream as a persistence. You can run it in Gitpod or just check it out and build it locally. So it is basically a Spring Boot application with a simple user interface, web user interface. You have the application mimics a bookstore company, or a company which has retail stores for books, and access for third-party systems or external systems is managed via GraphQL. Lucene is used for full text search. You can combine Lucene effortlessly with Microstream to get a good full text search index if you want to leverage that. So Microstream plays along with any technology you like. So use Spring Boot, use a micro framework of your choice, or just plain old servlets. It doesn't matter in any way. So the data model are just purchase, like Marcus showed you. No special split classes. Name this one of ours here. Basically, let's start with a simpler example. For a address with the address line, zip code, and a reference city. No annotation, no implement serializable and stuff like that, and then you're good to go. And Microstream takes third-party types as well, so you can use Eclipse collections or Google Guava, whatever you like, and Microstream will happily take the objects and store it. Yeah, that's basically your data model. We have example for lazy loading, of course. The purchases are not put into one huge list, but it's put in segments in business years. Down here you see a map with the year as key, and lazy reference to the yearly purchases, where the purchase objects are lying in 3 different maps again. So you can build kind of indices where you can access the purchases over shops, employees, or customers here. But don't worry, these purchases are not hold double in memory, but only the references, of course, like the object model is designed. And Microstream will only store the references multiple times, but they're the 8 bytes don't hurt too much. So you can design or split up your data model based on your business case. So you don't have to put your all your customers in a huge list, or all your purchases in a huge list, or in a table like in a relational database, but you can reference the objects from the fitting root objects. So you don't put it in big lists like you're used from the relational models. And that's the point where you have to change your mind. So you don't think in relational models anymore, but you think in objects, in object models, and design it not based on a storage system, but based on your business case. And that's a cool thing. You don't have to take or you don't have to adapt to the underlying storage system, but you can solve your business problem, and Microstream will just take the model as is. All right. So, and how do you start an engine? Maybe we can look in the hello world here. So the simplest way is you call embedded storage start, and you set the root, and you can then store the root or get the root with the root method here. And that's the simplest possible way to start up Microstream. And the root is basically the entry in your object graph where the persistent state begins.
So this would be like the equivalent of the entity manager and JPA, is that right?
Yeah.
Or is
for example, yeah.
Okay.
Yeah.
Got it.
Yeah, and this the storage manager can be configured as well, where your storage is, what backup, how many channels, and how big your files can get. And it's basically you can configure Microstream down to the last bit. Can exchange any implementation. It's basically everything's an interface in Microstream, so you can write your own application if you have special needs for that. That's not a problem at all. So, and that's basically all you have to do. You have a storage manager instance, the entry of your object graph, and you call your getters in your model, your lazy getters, and you call store of the storage manager, which writes, updates, or deletes the object in the storage. And basically that's it. All you have to do. You don't have any cache configurations, no Hibernate session management and stuff like that. And that's that's the most interesting part in Microstream. If you have not a lot of special cases, which maybe 95% of every real-world application is, then your code looks like that. A few simple methods, and you're good to go. And if some special cases are everywhere in every real-world application, so you can configure Microstream, or you can exchange parts, and change the behavior of Microstream. So example is you can use transient fields, for example. If you don't want to store a single field in an object, basic implementation or default implementation uses the transient modifier. If you want to use an annotation, just exchange the implementation, and you can use an annotation, if you will. Yeah.
So Scott had is there a tool to convert my relational data set to Microstream format, or would I just walk the data set with my current DBC object model?
Mm-hmm. Yeah. We tried to implement an automated tool, but then you have basically a set of lists which contains every single relational table, and that's not what you want. Basically, you can do it. You can import all your objects over JPA into your JVM and put it in a root object and store it with our storage manager, and then you have your data in Microstream. But the data model is very yeah, you have a bunch of huge lists for each table. That's not what you want. So we prefer to really make a migration to Microstream and redesign your object model from scratch. That's what you have done in 2 different projects, that you can leverage the power of the JVM fully, of course. But if it's good, you're good to go with a bunch of lists, and it's basically just an import of all your data from the database into an object graph and store it with Microstream. Yeah. So I guess we lost Jim.
Yeah, I'm dropping back. Yeah. Please carry on. If you can hear me, carry on.
Yeah, and one thing I wanted to mention is the configuration part. You have basically 3 different ways to configure Microstream. We have classes called foundations, basically build a pattern where you can put your configuration together, channel count, for example, or the file provider for the file system, or backup configuration, stuff like that. We have the external configuration based on external formats, XML, YAML, property files, whatever you can think of, and a specialized configuration layer, a general purpose configuration layer which adapts to a key value model. And we have adaptations, for example, for Spring Boot, Spring configuration, or for Helidon configuration, and that can be used as well. So you can put your Microstream properties into your frameworks configuration, and Microstream will read the properties out of the Spring configuration, for example. Yeah. Yeah, the legacy type mapping. The thing is, your classes will change over the time, and that's what legacy type mapping is for. So the simple cases, or the common cases, can be detected by our engine, but if you have more sophisticated type changes, you can provide a custom mapping by hand, by simple key value mappings as well, or you can inject custom legacy type mapping providers and can make your data conversion by code, so you can instantiate your fields differently, or you can modify your data, or for example, you have a change, you have a name field and want to split up the data to first and last name, then you can do it by providing a legacy type mapping provider for that special type. And Microstream will use it to convert the old data in the storage to your new object model. And it doesn't matter how many type changes you have. Internally for Microstream, it's just a new type with the same name, but a different structure. So Microstream doesn't care how many changes you have over the time, and will happily convert it through the different evolutions. And the storage garbage collector will take care of the older data, which then can be discarded later on. Okay, then the the conversion of the model is not done on bulk or in bulk. So if you change your classes and start up the application again, Microstream will not rewrite the whole terabyte of your storage, but will convert it on demand. Only if you load the old objects, the conversion will be done live. And you really don't have a significant performance impact, because mostly the fields are just put on different locations in memory, and that doesn't make a huge difference performance-wise. So don't worry if your classes change often. That's not a problem at all. Yeah. All right. So Jim will be back.
Florian, I have only some slides about serialization. Do we want to add this?
Yeah, why not? Sure.
Okay.
Sorry about that. My modem is not the most cooperative either. It's my internet provider needs to kick sometimes. But I'm back.
No worries. Okay, I like to add something to serialization, because with Microstream, you can use Microstream also for transferring data between JVM processes. And why you should do that? Java serialization is insecure, and it's a security risk. And the problem here is that code can be executed through deserialization, and so the bad guys can inject and execute malicious code through deserialization. And every year at the Oracle Code Conference, we have talks about this topic, and they show how easy it is to inject malicious code in the Java application, and actually it's horrible. So and with Microstream, we have fixed that, because Microstream works totally different. It works fundamentally different to Java serialization. And Brian Goetz also has described this problem on a blog post, and he mentioned that all the other serialization frameworks out there, they either they base on Java serialization, so they have the same problems, or they care for different formats like JSON. But then we have different challenges by using different formats. So it's not possible to serialize a complex object graph. So then you have limitations with other serializations. And Microstream is also a serialization that uses bytecode, and it's super fast, and it's not possible to execute code through deserialization, because we do not transfer any class information. We transfer data only. So it's not possible to execute malicious code through deserialization. And this is the reason why Microstream is highly secure. And if you have to build a high secure system, so perhaps Microstream is a very interesting option for you. And on top of the serialization, we have synchronization library where you can synchronize your object graphs. That's what I want to add here beyond persistence, what you can do with Microstream. Okay, what's coming next? We are working on integrations with microservice frameworks. We are currently working on replication. So if you want to build distributed systems using Microstream, then we need replication, and we're currently working on that. And we're also working on a Microstream cloud service, Microstream as a service, that enables you to set up your storage in the cloud super easy with only some clicks, some mouse clicks. That's coming next. Yeah, and that's it. If there are some questions about Microstream, please feel free. Take the chance. And also your comments. So it's very interesting to hear what you think about Microstream.
Yeah, I certainly have a few. And I saw that your demo is in Spring Boot, but you said that support for Spring Boot was coming later. Is that specifically for Spring Data, or is what additional features are you planning for Spring Boot? I guess I should ask.
We have an adapter for the Spring configuration, and we provide the dependency injection stuff providers where I can inject the storage managers based on the configuration. That's what I know. I'm not a big Spring expert, but we will open source it as well. So there will be news soon. Yeah. That's
Great.
what I know about the injection stuff.
Excellent. And then also you mentioned that the Microstream serialization can be used outside of Microstream, or so have you thought to reach out to any of the other tool platform kind of vendors that already work with multiple serialization formats to see if they could work with the Microstream serialization format? The one that comes to mind is Kafka, because they support Avro, they support protobuf, and they support JSON. But have you considered reaching out to them and to work with them to see if they could leverage Microstream, since it is so compact and efficient, and it could make for a unified serialization model, as it were, if the developer were to use Microstream as their persistence engine as well?
Yeah, we have prototypes for Kafka and Hazelcast currently.
Great.
And it's a little more work to do, but we made first contact on Code 1 2 years ago with Hazelcast guys, or 3 years ago actually. And if you're ready, I think it's a good alternative, of course, in different frameworks. And Kafka is our or we will bring a lot more stuff with Kafka in the future, based on the streaming. So you can use Microstream as a kind of a object mapper. So you transfer objects into topics without thinking too much about serialization, mapping, and class changes and stuff like that. Yeah.
That would be really nice too, because right now with, say, Avro, you don't have much in the way of an object graph model. It's just each is a single flat object with very primitive data types, and that's it. So yeah, I think that this would bring a lot of richness, while also allowing to use POJOs instead of needing to use AVSC text files, or say with protobuf, you still have to do some sort of generating of the types, as it were, with both of them. So yeah, this would be really, really nice to just be able to use POJOs.
Yeah, that's a trade-off of the multilingual serializers.
Yeah, it's true. Yeah.
And that's where we can shine, actually.
Excellent. I'm looking forward to that. Makes me very excited.
Cool.
And so, like with microservices, it looks like that Microstream isn't quite there yet with being able to scale out. Is that correct, or can you use it in a Kubernetes based context?
Yes, you can do that. So
Okay, good.
This is mandatory in many of our customer projects.
Okay.
That it can be used in containers and managed by Kubernetes.
Excellent.
It's possible.
Good. Did anybody else have any questions? Now's a great time to ask.
I'm looking at this as a potential tool for testing, and I don't know. I'm just wondering how would I convert my my relational data, or I'd like grab a subset of it. I'm just trying to visualize how I'd make this happen.
Yeah, a simple way to get it started is if you have a load a bunch of data from your relational database over Hibernate. For example, you have a object in memory. And then you just put this object into the Microstream storage manager and store it. And basically that's it. Yeah. So you can reload it with Microstream the next time you start up the JVM. For testing purposes, a lot of projects use the GMFS file system, so you have the file system in memory as well, and that's, I guess, the max performance you can get in testing environments, and you don't have to use a hard disk for unit tests. Yeah. As a side note, I think GMFS is in one of our examples in the repo. Yeah.
Okay, so I gotta say I like the name.
So yeah, in-memory file system from Google, which is an NIO implementation of the non-blocking IO layer in Java. Yeah.
All right. Any other questions? All right. Well, if you haven't clicked on the survey link yet, you can win great door prizes. JetBrains IntelliJ license for giving away a 1-year JetBrains Ultimate license, and then also got what else? Venkat Subramaniam's AgileLearner.com site. 1-year subscription to that is a fantastic learning website. A 1-year license from Structure 101 for their IntelliJ and Eclipse plugin. And then also a 1-year license for SonarGraph. It's also a refactoring tool. Again, Structure 101 is a refactoring tool, and SonarGraph is also a great refactoring tool. And also we have a Webucator training voucher to be given away. So yeah, please definitely sign up for go through that survey, fill out everything that you'd like to win, and they're all really great prizes. And I'm also looking for a speaker for next month. If you're interested in giving a talk or know somebody who'd like to give a talk, or if you just like to see some topic talked about, I'm going to see if I can reach out to somebody at Oracle and see if we can get Java 17 talk given, or maybe even if not Oracle, maybe somebody else who's really enthusiastic and up to date on Java 17. I'm certainly interested and very curious about it, and I hope you all are too.
Absolutely.
Cool. I'm glad. Yeah, anytime you have any ideas, please feel free to reach out to me and let me know. Jitha said, thanks, y'all, really cool. I absolutely agree. Thank you very much, Marcus. Thank you, Florian. This has been really, really great, very interesting, and very exciting too.
Yeah, thanks for having us. Yeah.
Thank you, Jim. Thank you, Java User Group Houston.
All right.
Have a great time. Thank you.
Thank you. Y'all have a good evening. Sleep well. I know it's very late for y'all. Y'all take care.
Thank you.
It was a pleasure. It was a pleasure.
Oh, it's been great. Thank you so much.
Thank you. Bye-bye.
Thanks, guys. This was really cool.
Thank you.